Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0404, indicates an EGR, exhaust gas recirculation valve, circuit range performance problem, specifically in the Honda Civic models from 2006 to 2011. An EGR valve plays a crucial role in reducing nitrogen oxide emissions by recirculating a portion of the engine's exhaust back into the intake manifold, enhancing combustion efficiency. Its location is typically between the intake manifold and exhaust manifold, and it connects via a 6-pin electrical connector. When this code triggers, it may indicate an issue with the EGR valve's ability to control the flow of exhaust gases. This could lead to performance issues within the vehicle or higher emissions, and troubleshooting is essential to identify faults within the EGR system or related wiring. The error code P0404 signifies a problem within the EGR valve circuit that affects its performance or range. The EGR valve is vital for reducing nitrogen oxides, NOx, in the emissions from the engine, as it recirculates exhaust gases to improve combustion efficiency. Typically situated between the intake manifold and the exhaust manifold, the EGR valve is connected via a 6-pin connector, which facilitates electrical communication for proper operation. If the EGR valve fails, it could lead to problems such as poor engine performance, increased emissions, or an illuminated check engine light. Understanding the role of the EGR valve and its exact location is critical to diagnosing and repairing the issues related to DTC P0404 effectively. There are multiple factors that can lead to the triggering of DTC P0404. First, a faulty EGR valve is a primary suspect. If the valve is stuck open or closed, it can disrupt the flow of exhaust gases. Second, wiring issues present between the EGR valve and the engine control unit, ECU, can result in poor communication, leading to erroneous readings or signals. Lastly, a faulty EGR valve connector can impede electrical connectivity, leading to performance issues or triggering the check engine light. Each of these possible causes directs attention to either the valve itself or the electrical pathways associated with its operation. When the DTC P0404 is present, several symptoms may manifest. Firstly, poor engine performance can be noticeable, as the engine management system responds to incorrect readings from the EGR valve, potentially resulting in reduced power and efficiency. Secondly, there may be an increase in vehicle emissions due to improper recirculation of exhaust gases. This could cause the vehicle to fail emissions testing if applicable. Last but not least, the illumination of the check engine light serves as an important alert for drivers, prompting them to seek further diagnostics. Awareness of these symptoms can guide drivers in determining when to take action. The first step in troubleshooting DTC P0404 involves turning the ignition switch to the on position, also known as II. This position allows the vehicle's electronic systems to power up without starting the engine, facilitating the collection of diagnostic data. Before proceeding, it is crucial to record all freeze frame data and any onboard snapshot data available, as they provide insights into the vehicle's conditions, leading up to the DTC being triggered. Additionally, reviewing the general troubleshooting information ensures a comprehensive understanding of the diagnostic pathway and potential complexities involved in addressing the EGR valve's performance. By following this initial step carefully, technicians can efficiently set the stage for accurate diagnostics. In the second step, clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. This process resets the vehicle's onboard computer and allows for a fresh assessment of the vehicle's EGR system function. After clearing the DTC, start the engine and hold it at 3,000 RPM without any load. ensuring that the automatic transmission, AT, is in either park or neutral position, while manual transmission, MT, should be in neutral. This step is crucial as it triggers the EGR system, allowing the technician to monitor its functionality under load conditions. By maintaining the engine speed at 3,000 RPM until the radiator fan activates, technicians can ensure that they are observing optimal operating conditions for diagnostics. The third essential troubleshooting step involves performing the EGR test using the Honda Diagnostic System, HDS, within the inspection menu. This test allows for real-time monitoring of the EGR valve's operation, assessing whether it properly regulates exhaust gas recirculation. Once the test is complete, check the results to determine if they indicate that the system is functioning correctly. If the result of the EGR test is okay, the issue may be intermittent. Thus, it's advisable to clean any carbon buildup on the EGR valve with throttle plate cleaner. Conversely, if the EGR test is otherwise, you should be prepared to move on to further diagnostic steps. In the fourth step, turn the ignition switch to the lock position, which is also labeled as 0. This step ensures safety before disconnecting any electrical components. Once the ignition is off, safely disconnect the EGR valve's 6-pin connector. This action allows access to the connector's terminals for further testing and diagnosis of the EGR system. Always take care when working with electrical components to prevent damage or faults. Properly isolating the EGR valve in this manner is critical for accurate testing while ensuring you are adhering to standard automotive safety procedures. Next, measure the resistance between EGR valve 6P connector terminals number 1 and number 2, while ensuring you have the proper tools, such as a multimeter. Resistance is measured in ohms, and in this case, an acceptable reading should show 100 kiloohms, KOhm, or greater. A reading below this threshold indicates a potential issue with the EGR valve itself or the wiring leading to the valve, which may need to be inspected further. If the resistance is 100 kiloohm or more, proceed with the next troubleshooting steps as outlined for further diagnostics. Such testing is essential for pinpointing faults in the EGR circuit, essential for reliable performance. In the sixth step, you will need to measure the resistance between terminal number 1 and number 3 on the EGR valve 6P connector. This step is critical to checking the electrical integrity of the EGR valve circuit. Using a multimeter, look for a resistance measurement of at least 100 kiloohm or higher. If the measurement meets or exceeds this threshold, it confirms that the wiring or the EGR valve is functioning correctly in terms of electrical resistance. On the other hand, a reading below this value indicates possible wiring issues or defects within the EGR valve that require additional inspection or replacement. Proper execution of this step aids in narrowing down the potential fault sources effectively. Finally, in this seventh troubleshooting step, check for continuity between terminal number 6 on the EGR valve 6P connector and the body ground of the vehicle. Ensuring proper grounding is essential, as it confirms the electrical circuit's stability and helps in preventing intermittent issues. Use a multimeter to check for continuity. An infinite reading indicates a break in the ground connection, potentially leading back to the DTC P0404 issue. Conversely, a successful continuity test confirms that the EGR valve's electrical circuit is solid, ruling out grounding issues as a fault source. Each of these tests forms a critical part of the diagnostic process, assisting technicians in determining whether the EGR valve or associated wiring is the root cause of the problem. Following the troubleshooting steps, The final repair verification is essential to ensure that the repairs made have resolved the issue indicated by DTC P0404. Begin by clearing the DTC once again using the Honda Diagnostic System HDS, and then proceed to conduct a test drive. Monitor the EGR valve's function during this drive, ensuring it works correctly under various driving conditions. Observing the operation of the EGR system in real time helps verify that repairs effectively address the issue and that no further codes appear. This testing phase is a critical step in the process, confirming the integrity of the repair and the vehicle's overall performance post-service. Preventive maintenance is fundamental to avoiding future occurrences of DTC P0404 and ensuring the longevity of your vehicle's EGR system. Regular inspections of the EGR system can help detect issues early, allowing for timely maintenance that can prevent larger problems from occurring. Additionally, using high-quality fuel and engine oil can aid in minimizing carbon buildup on the EGR valve, a frequent cause of EGR-related failures. By combining these preventive measures, vehicle owners can maintain optimal engine performance, enhance fuel efficiency, and reduce overall emissions. Proactive care can significantly extend the life of the EGR system, keeping the vehicle's performance at its best. In conclusion, addressing DTC P0404 requires a comprehensive understanding of the EGR system and its critical role in maintaining emissions standards and engine efficiency. Properly conducting diagnostics through systematic inspections of the EGR valve, checking resistance and continuity, is essential for identifying and correcting issues. As outlined, each troubleshooting step aids in narrowing down the causes of the error code, enabling effective repairs. Furthermore, implementing preventive maintenance strategies ensures lasting reliability of the EGR system while enhancing the vehicle's performance. A well-managed EGR system controlled fuel consumption, decreased emissions, and compliance with environmental regulations, solidifying its significance in modern automotive engineering. Please like and subscribe to the channel. See you next time.